So which trig function is the reciprocal of the sine? Cosecant. So I would like for you guys to use a different color than you did originally on this when you did the sine curve. So you can use a pen or a color pencil or whatever. So we're going to use the sine curve to graph the cosecant just by going to each little point that we graphed and graphing the reciprocal of it. All right, so I'm going to start at the far left with this point right here. So this point, the y, is -1. What is the reciprocal of -1? The reciprocal of -1 is -1. Yeah, you should have already done that. If you don't have it, then you're just going to have to hang in there. All right, and then here we have the reciprocal of the negative square root of 3 over 2. So we have 3 options. Which one? No, we're doing the reciprocal of negative square root of 3 over 2. It has to have a 2 in it. Right, 2 square root of 3 over 3. So it's this one right there. So you're graphing the point in the same vertical line. You're just doing a new y coordinate. Okay, so our next one is the negative square root of 2 over 2. So which choice do you think that is for the reciprocal? Yes. Right. And then the next one is at -1/2. What's the reciprocal of that? -2. So we are not going to use this negative square root of 3. So you can just mark that out. It's not going to be the reciprocal of any of the ones that we graphed. Okay, the next point is 0. What's the reciprocal of 0? Nope. Undefined. So where a graph is undefined, what you're going to have is a vertical asymptote. So we'll graph that. So we can't take the cosecant of 0 because it's undefined. All right, we're going to keep going. So the next point we have right here, the y is 1/2. What's the reciprocal? 2. So we stay on the same line, but we just move the point to 2. All right, and then this one is hard to tell, but it's the square root. Which one is it? Oh, it's the square root of 2 over 2. So that reciprocal is the square root of 2. And then the square root of 3 over 2 is going to be 2 square root of 3 over 3. And then 1, the reciprocal of 1 is 1. So you can also mark out the square root of 3. We are not going to use that line at all either. All right, so just keep going. So go to each y and graph the reciprocal. And I'm hoping you can see the pattern that forms. It's fine. Keep going. So anywhere there's an x-intercept, draw the vertical asymptote. I should have used colors that were more different than these two. Okay, so this is what your points should look like. And then I'm just going to connect them. So it's going to be a bunch of little parabolas. So the lighter blue is the graph of the cosecant of x. So it's going to be vertical asymptotes everywhere where sine is 0. So everywhere where there's an x-intercept, you draw a vertical asymptote. And then like at the top of the peaks, there's a parabola. At the bottom of the valleys, there's a parabola going downward. That's cosecant. So the period of the cosecant matches the period of the sine exactly. What about the amplitude? So the amplitude is going to be the distance from the midline to the highest point. Well, is there a highest point on cosecant? No. So there is not going to be an amplitude for cosecant. So if there's a question that asks you for the amplitude of cosecant, it's a trick question. There is not one. Okay, so on the back, we are going to do same thing, but with cosine. Okay, we're still not going to use the square root of 3 and the negative square root of 3. All right, so the reciprocal of cosine is secant. So I'm going to graph secant in green. So the first thing I'm going to do is everywhere where there is an x-intercept on my cosine, I'm going to do a vertical asymptote. And then I'm just going to go through my points again and graph the reciprocal of the y. So I'm going to start with this one. That's 1/2. The reciprocal is 2. This point is the square root of 2 over 2. Reciprocal is the square root of 2. All right, this one is the square root of 3 over 2. The reciprocal is 2, square root of 3 over 3. And then the reciprocal of 1 is 1. Right. And then all these little parabolas are symmetric. So you can go through that every time, or you could just graph it according to what you just did. That's what I do. Okay. And then the square root, not square root, the reciprocal of negative 1/2 is negative 2. So we're just going to kind of repeat that same pattern again, just upside down. So secant looks a whole lot like cosecant, just like sine and cosine look a lot alike. So it's just where you start and where you end is a little bit different. What do you guys think about the amplitudes? Does secant have an amplitude? No. All right. So now, if you all go to the little half sheet, we're going to fill in a couple more boxes. All right, so tangent, cotangent, which we haven't talked about yet, and secant and cosecant do not have amplitude. So those are all none for amplitude. And then the period of the cosecant and the secant matches the period of the sine and cosine. So that is going to be 2 pi divided by the absolute value of b. So b, if you guys don't remember, is the number that's multiplied by x. Sometimes it's directly multiplied by x. Sometimes it's factored out a little bit, but that's what b is. All right, so I'm going to give you guys the note sheet for today. Again, we're not going to, just like we did do on sine, we're not going to do all those many points. We're just going to do 5 and then draw our stuff. Okay. So I went ahead and I put the parent function of, yes, okay. I put the parent function of secant and cosecant on there for you. So just you'll have an idea as you're going. I am going to draw the sine and cosine in with that. Okay, so I know that cosecant is the reciprocal of the sine. So I'm just going to draw one little period of sine in there. You could draw 2 if you wanted. Oops. Just to remind you of the relationship between sine and cosecant. And then we'll do the same thing for secant. I'm going to draw a little cosine graph in there. It's one period. A Texas Longhorn graph for cosine. All right, so we're going to go straight into a couple graphs. But before we do the graphs, we're going to find the period and the horizontal shift. That is nothing different than what we have been doing with sine and cosine. Okay, so the period for secant and cosecant and sine and cosine is 2 pi divided by whatever is being multiplied by your x, which in this case is pi over 2. Or 2 pi times the reciprocal of that. So what do y'all think? What's that going to be? 4. All right. And then for the horizontal shift, it could be written one of 2 ways. When it's written this way, it's a little better than when it's written the way it is on B. So when it's written this way, they've kind of already divided it out. And so if we're looking for the horizontal shift, we're just going to use whatever that number is. So it's going to be 1 unit, and then which direction? To the right. Now, to be able to get a cosecant graph, we're going to have to graph a sine graph first. All right. So first, we're going to graph the corresponding sine. So all the numbers and stuff is going to change the same, but in the place of cosecant, we're going to replace that with sine. So it's going to be 3 sine of pi over 2 times x minus 1. Now, the cosecant graph does not have an amplitude, but the sine graph does. So let's write it down. So it's the amplitude of the sine graph. What do y'all think? Just 3? Yep. All right, and then the period of the sine is going to be the same as we just found for cosecant. The shift is going to be the same. So we actually have everything we need to do the sine graph. So we'll go ahead and draw kind of a long x-axis. What we're graphing first is this one. And so this one has the same horizontal shift. So what are we going to put right smack dab in the middle of this line? 1. So 1 unit to the right is going to have that point at positive 1. All right, what about over here at the end of that period? 5. And to get the 5, we just take the 1 and we add the period to it. All right, so if you guys remember, sine has 5 key points. These are 2 of them. So we're going to want the one in between those, which is going to be at 3. And then in between those. And this is a nice one. Like this one, it's just the normal number line. So it's a little easier to do than some of the ones that are fractional or go up or down by more than 1. Okay, what is this going to be? -3. So we take the 1, and now we subtract the period. So that's going to be -3. All right. And so same thing, we're wanting to find all these 3 other points. Now, once you see the pattern, I would probably just put the marks and then just label them following the pattern. Okay. What else do we need? The y-axis. And wherever x is 0, that's where you draw it. I'm off slightly. It's okay. All right, and then we're going to put the amplitude of sine on it. I'm not going to put it at the very top because I know that I'm going to have to do these little parabolas above and below 3. So I'm just going to kind of put it in the middle. Your scale doesn't have to be like perfect. It's okay. All right, that's our y-axis. Okay, so we're ready to get some points for the sine. So if you guys remember, sine always looks like that. Might be shifted, moved around, stretched, but that's what it looks like. So when we do our first point on sine, it's going to be in the middle. And then as long as it's a positive sign, it's going to be a max, middle, min, middle. And just keep repeating that pattern, please. And then my students usually figure out that these points are really all you need to do the cosecant. So it's up to you. I like to just draw a little sine curve. I don't know. I'm weird. It's kind of fun for me. But if you guys just want to use those points, it's okay. But I'm drawing it dashed because our answer is not the sine curve. Our answer is the cosecant curve. Okay, so you've taken care of the first step, which is to graph this. So now we're ready to graph the cosecant. So anywhere where you guys see an x-intercept, what do you need? Vertical asymptote, good. Because anywhere where sine is 0, the cosecant is undefined. So we can't take the cosecant, or in this case, we can't put in -1. It gives us something undefined. And all we're going to do is just draw some little parabolas. And so your parabolas should bump up against these sine curves. So at the top of that little hill, I'm going to draw a parabola going up that just touches it and bounces away. And then at the bottoms, draw a little parabola going down. Same thing, bumps it and then goes the other way. All right, there's 2 periods of cosecant. All right, do you guys have any questions? Okay, we're going to do one more. We're kind of running a little low on time. Well, I think we'll be okay though. All right, so you guys go ahead on B and figure out the period and the horizontal shift, please. It is a little more difficult to do the horizontal shift than the first one. All right, so period 2 pi divided by whatever is being multiplied by x. And so what would that end up being? 12. All right, this one, since you don't have parentheses inside the parentheses, you're going to have to do what we put on that little half sheet where you take this, which is considered to be C, and divide it by this, which is considered to be B. And what does that give you? 3, right? Yep. And what direction? Left. Good. So a plus means we're going to shift to the left. Matthew, are you taking pictures of me? Okay, just making sure. Okay. All right, so first we're going to graph y equals -4 cosine of all that stuff. All right, now again, secant does not have an amplitude, but the cosine that we need to graph before we graph secant does. And what is the amplitude of it? 4. All right, we have all our things. Okay, so what do y'all think about this middle number? Yes, -3. So 3 to the left for your horizontal means smack dab in the middle is -3. And then we add the period to get this end. And then we find our halfways. Sometimes when it's a negative and a positive, it's kind of hard to do in your head. But if you can't, you just add them together and you get 6 and then divide by 2. So that middle is 3. That middle isn't hard. That's just going to be 0. And then you can tell, I think you should be able to tell that you're just bumping up by 3 each time. So we could go through the process of averaging it if you wanted to, or just bump by 3. All right, and then I'm going to do a period on the other side of -3. So I'll take -3 and subtract 12 from it. And then I'm just going to go by 3s. All right, so that's my x-axis. And I'll draw my y-axis. All right, now I'm going to put 4 and -4 kind of in the middle of those. Right. So one period of normal cosine looks like the Texas Longhorn. This is going to need to be one period of negative cosine. So it should be reflected on the x-axis. So you start with a minimum and then a middle and then a maximum. Okay. And then it's just vertical asymptotes and parabolas is all we have left to do. So the middle points become vertical asymptotes. And then the max and min points have little parabolas touching them. And that's 2 periods of secant. Right. What questions do you guys have? Okay. We have 2 more to do, and they're writing the function. Now, we didn't do any of that yesterday, so hopefully you'll remember from last week how you do that. Okay, so I'm going to say these two, there is no shift horizontally. There is a shift up and down, but we're going to do this like there's no horizontal shift because we can do multiple equations. But if we just try to think of it like not shifting left and right, then we can figure this out easier, I think. So what is the midline? Like what's the middle? -1. All right. Now, I didn't make this super clear earlier, so I'm going to do better with you guys. So now we're going to start at the y-axis, and we're either going to draw a sine curve or a cosine curve, but they both kind of look the same. They're both kind of curvy, obviously. So I'm going to start where this one starts, where I have something, and then I'm going to curve it down, and then I'm going to touch it there, curve it up, touch it there. What does that look like? Cosine. So this should be a secant graph. If we're saying there's no left or right shifting. Okay, so we still need the same things we did before. We're going to need the amplitude of that little cosine curve I drew. What do y'all think? From the middle to the highest point of the cosine, 2. All right, and then I'm going to need b, or that's the number multiplied by x. So to find that, you need the period. So the period of the secant and the period of the cosine are the same. So this is 1 period of cosine. So how long is that? 4. So it went from 0 to 4. So it's going to be 4. Do you guys remember what we did with that to find b? 4 equals 2. Good. All right, and then we can just switch the 4 and the b. So b is pi over 2. All right, so if you're looking at that little half sheet that we just filled out, I can't pull it up real fast because it's on another lesson. That is going to be b. 2 is going to be a, and -1 is going to be d. And we're just going to fill it in. So it's going to be y equals secant. Oh, just kidding. Y equals 2 secant of pi over 2x minus 1. Okay, I think that's pretty advanced trigonometry to be able to pull all that stuff out. Okay, we're going to do one more. What do you guys think the middle is? Looks like 1 to me. Okay. Now, on the last one, we actually like had a blue line or a darkened line on the y-axis. This time we don't. So the reason we don't is because we would be starting at that midline and then curving up to a maximum, down to a minimum. And then this one doesn't finish off the period, so I'm just going to kind of continue it out there. So this time, that little dashed line looks like a sine curve. So this should be cosecant. All right. So we're going to do all the same things we did on the last one. We need to find the amplitude of the little sine curve we drew. And we need to find the period, which this one is kind of more difficult because we don't see the end of the period. If you guys were going to guess, what would you guess? 8 is right. You don't necessarily have to guess. You can see half of a period. So just one little hill or one little valley is half of a sine curve. And that occurs at 4. So a full period would be 8. Sometimes they put these on the ACT where you don't see the whole period, but the choices are obvious which one it has to be. Like there will be some that there's no way the period can be that small, and so you'll just pick the one that looks right, or you can pick out half a period and double it. Okay, so let's figure out what B is. They do like to throw in the actual sine curve or like you have the equation and ask what the period is. I mean, they typically will put one of some kind of sine or cosine graph on the ACT. All right. So we have all the things we need. Why don't you guys try to use these things and write the equation of the cosecant graph, please? All right. Any questions? Okay. So your assignment is just 4 problems down at the bottom. So 2 graphs and then 2 to write the equation. You